Hi everyone, welcome back. So this time we're going to be going over how things connect and the common units for density. So let's jump into this, and I'll move myself out of the way once more. There we go. Okay, now if we look at our equations from earlier, what you're going to see is that you see mass a lot. And this is a good thing because it tells us how it's often, not always, going to connect. In many cases, you're going to use the equations that you know to solve for mass to get to the thing you want. Maybe you'll know a force and the acceleration. You can use it to excel for mass. And from that, you can calculate a density. Maybe you know the weight. You can calculate mass, and you know volume. You can calculate density. So it's always, well, not always, but it's often going to connect through mass. Not always. Now, I said specific gravity is great for converting between densities. The reason for that is, as you can see over here, density is fairly easy to convert. However, it's a pain if you're not careful, because while converting the mass dimension is very simple, it's one step. You have 10 kilograms, want to go to pound mass, well, it'll be 2.205 pound mass per kilogram. This is a conversion you have in your book. That's all normal. Okay, so that would leave us 22.05 pound mass per meter cubed. If I want to go to feet cubed, what do I do? Well, I keep on going through. And what I find is that my 22.05 pound mass, I want to get the meters cubed conversion. There is no meters cubed to feet cubed conversion in your book. It's only got meters to feet. And so what you have to do is you have to do that conversion 3 times, which is fine. That's not too hard to do. The issue is that you will forget. Most people forget and then they get the problems wrong. And so in your homework problems, the lesson problems, there's plenty of them to let you make this mistake. And I will tell you if you've made it. I try to program that in there that gives you that little feedback that says, hey, you forgot to do this equation. You're supposed to do the conversion 3 times. But either way, you need to remember that if it's cubed here, then you cube the conversion. Unless you're using some sort of volume conversion, there are a few of those. Now, why is specific gravity amazing? Because you can look up the density of water in every unit you need. For example, let's look at it this way. So the density of water in pound mass per foot cubed is 62.4. Density of water in kilograms per meter cubed is 1,000. So if I want to convert this to pound mass per foot cubed without having to worry about that whole cubic conversion, I can first calculate specific gravity. So specific gravity would be equal to 10 kilograms per meter cubed over the units I need, which is kilogram per meter cubed, so 1,000 kilograms per meter cubed. Okay, so I did that. It comes out to be 0.01. That's the specific gravity. And then I can then calculate the new density in different units by simply multiplying it by the density of water in those units. So I multiply by the density of water, which is 62.4 pound mass per foot cubed. And I get 0.624 pound mass per foot cubed. This is amazing, especially let's say I had gone to some crazier unit which doesn't have a nice conversion. If you have the density of water in that unit, you can convert in 2 steps. Calculate specific gravity, calculate density, you're done. So, and you see we got the same answer except for a couple sig fig I lost because the value I use is a rounded value. Okay, so this is why it's important to learn specific gravity, because it will help you so many times. But please remember, specific gravity is not gravity, it is not specific weight, it is something completely different. It is a ratio, it is unitless. Use it as such. With this though, we finished density and specific weight. I hope this helped you. I'll see you all next time. If you have questions, please email me. Bye-bye.